Hi everyone, this is going to be a workshop on MergeSort. It's kind of similar to quicksort in a sense, where you have to divide into subarrays in order to solve the problem, which in this case is to sort the array as quickly as possible. The thing is, quicksort has, in the worst case, it has big O of n squared complexity, which is the same as selection sort and so on, but this happens very, very rarely. Like, I think the worst case is when the array is sorted backwards, like if it's 8, 7, 6, 5 and so on up to 1. I think this is the worst case, and then you have this kind of complexity. In most cases, like the average case is O of n log n. And now we'll do the merge sort, which always has this complexity. It works a little bit different. Alright, so the merge sort, we just start with an array which is not sorted, so 7, 1, 2, 5, 4, like 1. Okay, we split it into two arrays. Okay, one here, one here. This is going to be 7, 1, 2. This is going to be 5, 4, 1. We split that as well. So 7, 1, 2, 5, 4, 1. This is going to be 5, 4, 1. And then we split this one as well. So this is going to be 7, 1. We'll have 2, we'll have 5, we have 4, we have 1. Okay, and we end up with arrays of size 1, which are sorted like between themselves. Okay, so each array of size 1 is sorted, and the idea behind this this algorithm is that it's very, very easy to merge two sorted arrays. So let's say here now, if you want to merge the 7 and the 1, it's very, very clear. It should be 1 and 7. Okay, if you want to then merge it with the 2, it's clear how that's going to happen, 1, 2, and 7. I'll go into a bit more detail about this specific step in a second. Then on the right side, we'll end up with 1, 4, and 5. And then we just have to compare these two. Okay, so now let's start again. So the idea is that you start with a single element. All of the elements of the array would be in some sense arrays on their own, which are sorted. Okay, so we don't have to do any job there into splitting. And after that, it's a lot easier as an algorithm to sort two arrays, to merge two sorted arrays into a new one that is sorted. So let's start. Let's do this specific merging step, which is going to be the most important thing here. So let's say that we have two arrays. We assume that they're sorted already, and we want to merge them into another one. So let's say that we have 1, 2, 7 and something like 2, 4, 5, 8. Okay. We'll have another array here where we have to place the element. So how does this go? Okay, so we start with the very left on the one array and the very left on the other array. Okay, so which one of these two is smaller? It's the one. So we write it here. And we move the cursor, so it's like we delete this. We move the cursor one spot to the right and make the same comparison once again. Okay, so we'll have the 2 and 2. Okay, so both of them are equal. So we just say this 2 is here, this 2 is here. We move the cursors. Now we have to compare the 7 and the 4. The 4 is less than 7, so we write it there. The cursor here moves one more step. Comparing the 5 and the 7 means that we have to put the 5 here. Destroy that, then move to the 8. Which one is smaller? It's the 7. Okay, we don't have any more elements here, which automatically means that we can just rewrite all of the elements on the right side here. So this is going to be the 8 here. Okay, is it clear? Okay, and please think that okay, so what's the complexity of this step here, of this step that I just described? What's the okay, so someone says n squared. Why do you think it's n squared? Okay, we just go through all of the elements once, right? We don't have nested loops or something. We just have to go through all of the elements once, which is complexity like n. Okay, so O of n. And what else is it that's gonna slow down the algorithm? It's the number of splitting into two steps that we have to do. So how many splits do we have to do until we reach arrays of size 1? In this case it's 3, okay, but let's say that we have like array of size 10,000, then how many splits would it take? Okay, let's do that in a bit more detail. Okay, if we have four elements, how many splits is gonna take? 2. If we have an array of 8 elements, let's say that those are 8. How many are we gonna need? 3. If we need if we have 1024 elements, how many steps is it gonna take? 10. Okay, so 2 to the power 2 gives me the number of elements. 2 to the power 3 gives me the number of elements here, and 2 to the power 10 is the number of elements. So this is going to be 10 steps in which we have to split. So this is like the binary search, right? Something similar, you know. So yeah, we it will take only 10 splits, but we still have to take this into consideration. So this is going to be n log n. Okay, because log base 2 of this is going to give me the number of extra steps that I want to do. Is that clear? Is that clear? No? Yes? Alright, so let's go into, I find this one to be a bit easier because whatever the algorithm is what we will write down. It's not like quicksort where you have to come up with those left and right indices and the swappings and so on. Whatever I just described is what we will be using. So let's create a method which is going to be called private static int MergeSort, which is just going to take an array. Alright, so if array.length is less than or equal to 1, return, okay, else return array, sorry. Okay, else let's start thinking what's the first thing that we have to do. Okay, first we have to take the middle point of our array, right, so that we can split it into 2 and so on. Okay, so int midpoint equals array.length divided by 2, and then we want to say we'll have 2 arrays. One of them is the left one, so there's going to be new int of midpoint elements. So if we have 8 elements, the midpoint is going to be 4, and in the left array we'll just have 4 elements. Okay, then we'll have the right one, which is going to be new int, and if I put midpoint here again, is there going to be a problem? Yes, no? What happens if we have 9 elements instead this time? Okay, so for the left part we'll have 4 elements, which is fine, but for the right one we would like to have 5 elements. You can do it the other way around, but you know, I think that this is easier. So the right, it clearly is not midpoint divided by 2, because 9 divided by 2 without a remainder is going to give me 4. So I need to do something that is going to work for both cases. Okay, so there's going to be array.length minus midpoint. Is that going to always work though? Okay, so what's going to happen if we have 8 elements? It's going to be 8 minus 4. I guess that's going to work. I did something different, and we'll have to check this. Of course, I did array.length plus 1 divided by 2. And then if we have 8 elements, we'll have 9 divided by 2, which is going to be 4 elements in the right array. And if we have something like 9 elements, then we'll get 5 elements for the right array. But I think that this one is going to work as well. So, sorry? This thing, or which one are you are you talking about? This way or this way? This one. So this is not gonna work for 8 elements. You think why? Okay, so midpoint. If we have 8 elements, midpoint will be 4. Okay, so the left array is gonna have 4 elements. And the right one is going to have 8 minus 4, which is 4 elements as well. So I think that this is going to work. If there is some error, I'll just change it with that. But yeah, this is fine. Okay, and then what is it that we want to do? We want to copy all of the elements from our original array into the left one and into the right one. So this is going to happen with a simple for loop. I from 0 to midpoint. And then we'll have left of I equals array of I, and then I have to do the same thing for the other array, but instead of having some complicated calculation, because for the right one we still have to start from 0, but we have to take the elements from the array which start in the middle. I'll just have here an index called j, which is going to start at 0, and it's going to track how many elements do I have in my right array. So another for loop here, which is going to start from midpoint. It's going to start from the midpoint, and it's going to go all the way up to array.length. Okay, and then we want to say right of j equals array of I, and I want to say j plus plus plus. Okay, I could have done something along the lines of what is that going to be? Something like I minus midpoint. I think it would work here as well, but I think it's clearer this way with the j starting from 0. Alright, so what is it now that we have to do? We have to sort each of them separately so that we end up with sorted arrays. Then we have to merge. Okay, so we have to do left equals m sort of left, right equals m sort of right. Oops. And finally, so these two steps are gonna ensure that the left and the right are now sorted, and then we have to merge them into a new array that's gonna be also sorted. So merge, just merge please, left and right, and then we have to return result. Now I see that for some reason result, where is my results? Why don't I have a result here? I have to put it up here, I guess. So int result equals new int of array.length. Okay, is it clear what we are doing. So it's like here we are splitting the array into two parts, whatever we are given as an array at this step. We split it into two parts. We copy the elements, we sort the left and the right, okay, and then we would like to merge those two arrays into a sorted one once again. Okay, is that clear? Everything clear? Okay. Okay, and of course this is gonna end, since at some point we will reach this stage where I told you that we'll end up with, you know, single element arrays, which we will just assume that they are sorted. So once we are there, let's say that we have these two elements, which is going to be our left and right. They will already be sorted here, so we'll have to do this step, which is going to merge those two, and we'll start with just two arrays with a single element, and then we'll go on to bigger ones. For now, this is just going to, you know, split the arrays into equal parts until it reaches ones with length 1. Alright, and the important one to write is this one. Okay, the left and the right. So the merge algorithm. Okay, up to here everything should be fairly simple and straightforward. Okay, so what is it that we have to do here? We'll need some variables. Okay, so int result length equals left.length plus right.length length. Okay, so this is going to be our resulting array that we have to, you know, give in the end. Okay, so int result equals new int result length. Okay, and as I was describing the algorithm, we'll also need, similarly to quicksort, we'll need a left index, which is going to start from 0, a right index, which is going to start from where? Sorry? Nope, it's not the result length. So remember, we have two arrays, the left and the right one. We start from here. This is the left index, and what is going to be the right index? It's going to be still 0, right? Because these are left now for the left array and for the right array. Okay, after the split. So this is going to be the right, and it also has to be 0. This was a trick question for which I am sorry. Okay, and then we'll have another index, which is going to track where we are at in our result. So it's going to be result index equals also 0. Okay, and now we'll just write the merge step, which is not that complicated once you think about it. So we have a left cursor, a right cursor, and we just compare this element against this element, and we just put it in the result array. Okay, if we've put something, so let's say that I've put something from here. Okay, I write it here, increase result index plus plus, and I also increase this index here. Okay, so left plus plus. Okay, and then we do the same thing, right, until we run out of elements. Is that clear? That should be fairly simple to write down. Alright, so we'll have a big while loop, which is going to be left index is less than left.length, or right index is less than right.length. Okay, so while we still have left and right, which are inside the corresponding arrays, then we want to do the operation here, which is just going to be, you know, comparing and so on. Okay, so if left index is less than left.length, or right index, I'm sorry, this is an AND, or right index is less than right.length. Okay, so we have to split this into sort of two parts. Okay, if we do have elements, I'm sorry, these are too big, I'll just write them again. Okay, so if we have elements, so let's say that the left and the right are somewhere in the middle, we know that we have to compare the elements and add them to this array, right? But we also have another case where, let's say that we've run out of elements from the left, okay? Then we just need to copy the rest from the right, okay? So these are like the two cases that we have to take care of, okay? And this is the first one where both the left index and the right index are somewhere in the middle, which means that we have to do some comparison. Otherwise, we would just have to copy the remaining elements from whichever array has its index in the middle, right? Because this can happen, right? Let's say that here I have 1, 2, 3, and here I have 5, 6, 7, right? So compare the 1 with the 5, write it here. Compare the 2 with the 6, write it here. Compare the 3 with the 7. Oops, sorry, this is 2. Sorry. So 1 with the 5, we write the 1. Compare the 2 with the 5, we write it here. Compare the 3 with the 5, we write it here. Okay, and after that, this is empty, and we just have to do those. So that's that kind of case that we have to take care of a little bit later. All right, so if this thing is true, then we want to check whether the left element is less than the element from the right. So we just have to compare the two. So if left of left index, the current index, is less than or equal to right from the right index, then we just have to say result of result index equals left of left index. Oops. And what is it that I have to do after that? Increment the left index and the result index. Okay, so let's do the other one. So else, what is it that I have to do here? A result of result index equals right of right index and right index plus plus and result index plus plus. Okay, this was that if here, and now we just have to check in some else statements whether we have to copy elements from the right or from the left. So this is going to be else if left index is less than left dot length, which means that we still have elements from the left subarray. What is it that we have to do here? Sorry? Loop? Not necessarily. We have a loop already, this while, so it's gonna still, go on. Because here we have an or. Okay, so we'll still get in here, so there is no need for a loop. We can just do this. Right? This means that we still have more elements from the left, and we have to do the same step that we did up there as well. And also else if right index less than right dot length, and I have to do this thing here. This means that we still have elements from the right subarray. And finally, we have to return the result, but I have no idea where. Is it here? Return result. Which one is this bracket? Yeah, okay, so it's here. And that's it. Okay, most of the code is just... So, right, this was the important part of this algorithm, and it's pretty straightforward, I think, once you know what's going on. Let's test it. So let's create an array. Let's create a random array. Okay, so int array equals new int of, I don't know, 10 elements is good for from 0 to array.length. Array of I equals, let's have a random. So random rng equals new random. and here we'll say rng.next, let's say from 0 to 10. Is that good? I think that's alright. And then we want to say array equals MergeSort of array, and we have to print string.join comma space array, control C. Once we've created it, I want to also print it. Alright, let's run this. If it doesn't work, I don't know, I'm not sure whether that's gonna work from the first go, but okay, so it works fine, I think. Let's try a couple more. Okay, so here we have more similar elements, so I guess that works as well. Oops. Yeah, I think that's fine. Alright, so that was MergeSort. I think it's easier, and as we discussed, it's quicker as well than Quicksort, and this is very widely used. The only other one that is like properly used is HeapSort, but that's kind of complicated and long, and you know, I just don't want to get into it, at least not in this course. But yeah, I think that's, you know, it's longer in code, but most of it is either repetitive or pretty straightforward, I think. So yeah, that's all. And to those of you who are waiting for the Unity videos, those will take some time to translate, so I'll try my best to do it, but I can't tell you when that's gonna happen. Sometime in 2016, maybe in the first quarter or something. I'll just try to translate those and put them up online. So yeah, this is that's it for the algorithms part of this course. I'll have all of the codes like from the homeworks and from the lectures on our website, so feel free to check that out as well. And that's it, and I'll see you in another lecture.